All right, so we're going to take a look today at a couple of the problems still for the chapter 4, 5, 6 test. So this one is number 32, and it's talking about some planting of corn that was done and the yield that was taken from 16 plots of land. Each of these, it looks like it was an acre, and so here were the number of weeds that were allowed to grow in each of the plots. 4 of them had 0, 1, 3, and 9, and then here was the yield for the corn. What it asks us to do is first talk about the explanatory variable and the response. They're thinking that the more weeds that you have, the less corn that you have. So there's my explanatory and response variables. So my x's and y's if I were graphing this one way. The second thing they ask to do is make side-by-side stem plots. Now I don't necessarily think the stem plot is the greatest idea for this one, but I'm going to make the stem plots. The idea side by side, we're going to do each of the 4 groups. So I'm going to look at the first 4, and I'm going to split my stems here. So I'm going to do, here is 1, 16, 16, 17, 17 for stem plot 1. And I have a 166, so I'm going to round that up to 167, a 172, a 165, and a 176.9, so 177. So there's the first stem plot. Now I'm going to take a look at the next 4. Again, this stem plot looks like it's got a 15s in it, so I'm going to have 15, 2 16s, 17s, and I'll add more if I need them. But I've got 166.2, 157.3, 166.7, and 161.1. If I do the next 4, 158.6. Here's my 2 16s, 176.4, 153.1. So now I have one way down here, and 156. And the last one I've got, looks like all the way down to a 14, 14, 15, 15, 16, 16, 17, 17. And remember, when I'm doing that, I'm doing the first half and the second half of them. So down here, I've got a 162.8. I've got a 142.4. Another 162.8 and a 162.4. All right, so there's my 3 stem plots that I'm taking a look at. And I'll notice that in 2 of these stem plots, especially down here, it looks like I might have an outlier here and here for the last 2. But overall, I was taking a look at, this was the stem plot for the 0s, this is the stem plot for the 1s, the stem plot for the 3s, and the stem plot for the 4s, or for the 9s, excuse me, 9 weeds. All right, the next thing that it asks is give the mean yield for each group using the unrounded data. So just plug these into a calculator, and the mean yield for each of the groups, and I'm going to write them up here so I can see it. But the mean yield for the 0s ended up being 170.2. For the 1s was 162.8. For the 3s, 161, and for the 9s, 162. All right, so my first glance, I'm looking at when there was no weeds, I had a much higher average than when there were 9 weeds here. Okay, but for the most part, once I got a single weed in there, whether it was 1, 3, or 9, it didn't seem to affect my score too much. All right. The second thing that it asks us to do is to use the median. And the reason they ask us to use the median is because a lot of these look relatively skewed. Like this one kind of goes like this one kind of goes like that. This one has a piece of data way out there as an outlier. Same thing over here. So that skewed data, they don't look relatively normal. I'm going to guess they wanted us to look at these. And they say it's not too abnormal because I only have 4 pieces of data anyway. But the average, or the median now, for this one was 169. The median here was 161. The median here was 157. And the median for the last one was 162. In fact, I actually had this wrong. This one, the average was 157.6, and the median was 162. All right. So again, when I'm taking a look at it, I will notice that there seems to be a big drop off going from here to here, but then these ones are relatively close together. Okay, so it really seems like once you get a single weed involved, it has a pretty dramatic effect on it. But whether or not the difference between 1, 3, or 9 weeds doesn't seem to make as much a difference. So the conclusion in this case, in my conclusion, I don't think it really affects it. It does just kind of emphasize the fact that there's a huge difference between the average and the median in some of these cases, especially the two where I thought they were the outliers. So 161 to 157, 162 to 157.6. But otherwise, I would say no weeds is definitely the best. Once you get a weed, it doesn't matter too much, but the number of weeds doesn't make a huge difference. Once you have one, you've got one. It doesn't make a huge difference after that whether you have 1, 3, or 9 in those 3 cases. All right, the second part of that same problem has me now take a look, since it is 2 variables, it has me take a look at the scatter plot for this. So I'm going to insert a chart for this data and make sure that it's my scatter plot. All right, and there it is. Once I look at that, I mean, to me, it looks relatively scattered. I've got some outliers out here, but here's that, and these were probably the 2 we talked about before. But this data, I'm going to go ahead and put a trend line in, and I'm going to take a look at the equation and the r squared for it. Now, whenever I'm taking a look at these things, I also want to find the correlation. So I usually use the choral formula. And here's my y's, here's my x's. So I have a correlation of negative 0.45. All right. It asks us, what does the slope of the fitted line tell us about the effect of Lamb's quarter on corn yield? All right, so the slope, negative 1.1x. I'm going to do it over here. As I'm taking a look at this equation, y equals negative 1.1x plus 166. Remember that x was my corn, or excuse me, x was my weed, and y was the corn. So this tells me that each increase in weeds, so we're taking an increase of 1, as it went up 1, my corn yield, spelled that wrong, my corn yield decreases by 1.1. That's always the key. Describe it in terms of one of the x's. Every time an x increases by 1, in this case, every time there's an extra weed per acre, there is going to be a decrease in corn yield of 1.1 bushels per acre, just because that's what the things were. So that's what the slope is telling me. But then it goes on and asks to predict these conditions for 6 Lamb's quarter plants per meter per row. So if I were to put 6 of those weeds in here, I'd basically be doing y equals negative 1.1 times 6 plus 166. And plugging those numbers in, I would end up with 159.4 is my predicted yield. But it goes on to ask me how reliable, well, it doesn't really ask this, but it points it out. This isn't a very reliable prediction. The reason for it is my R was negative 0.45. And it's not the fact that it's negative. It's the fact that it's closer to 0 than it is to negative 1. Makes that a weak correlation. In fact, if I look at the R squared, it says 0.209, which means that this really describes about 21% of the variation. So some of this variation is just random. And you can see it as you're looking here. I've got some variation that's completely random looking. Now, keep in mind, this piece of data right here, the 9/142.4, that might be an outlier. I'm going to take that out of here. There was another one that I looked at in the previous ones that we thought could be an outlier, and let's just take it out and see what happens. The 177. So where was the 177 in my graph? I think it's this one right here. All right, I'm just going to take those two out of here, and I'm going to notice that the R squared is still really, really low, 0.098. In fact, those two, when I put them back in, those two pieces of data, this one right here especially, is really affecting this line. This one, not so much. When I take out the first piece of data, my R squared dropped, but the second one didn't drop as much when I put it back in. So you'll notice the line doesn't shift as much with that one as it does with this one. I mean, the whole graph kind of shifts, but it's not enough. Even taking out those outliers really doesn't increase it. And again, you can see the scattered, so you can kind of tell this isn't something that I would use this line to make a prediction for. All right, so the number 34 talks about catalog shopping, which no one does anymore. At least I don't think so. What is the most important reason that students buy from catalogs? And it says the answer may vary for different groups. Here are the counts for samples of American and East Asian students at a large Midwestern university. So the first thing it asks us to do is to give the marginal distribution. They actually already started this for us. What I mean by that is the marginal distributions are the things that end up in the margins. All right, so they've got one down here and down there. They put the totals for us. So really all we're doing here is putting the totals of how many people do it to save time. We're just adding together all of these things, 11 plus 4 and 10 plus 3 and 20 plus 7. We have that total, and there's a total of 184 students, but these are the marginal distributions. Then it says give the two conditional distributions of reasons for American and for East Asian students. Make a graph of each conditional distribution. All right, so as far as the conditional distribution for each one, and you have to think about this, I'm talking about American students, what percent of them do it to save time? What percent of them do it because it's easy, because it's low cost, because they live far away from the store, no pressure, or other reasons? That, for each one of those, I'm going to do the same thing, which is I'm going to do 29 out of the total Americans, and 28 out of the total Americans, and 17 out of the total Americans. I'm going to do the same thing for the Asian students. I did that already, and I basically divided all these things. So here are the percentages for the American students. Here are the percentages for the East Asian students. And it asked me to do a graph of each one. So I'm going to put in a chart. In this case, I am going to, because it's percentages, and we don't do a lot of them, I'm going to make this a pie chart. And I'm going to do the same thing for the East Asian students. And I didn't put the numbers in here, or I didn't put the actual totals in there. I probably should have, but it'd make it easier when I look at this. But I'm looking at it and I see that the majority of Americans, I shouldn't say a majority, almost a majority of Americans do it for the first two reasons, save time and easy. Whereas when I look at the East Asian students, the majority of them do it because it is a low price. All right, so that's one way to kind of show those. So that's, to me, that's the biggest difference between those two students. You could also look here and see, one of the differences is kind of highlighted by the fact that only 15% of Americans do it because of the cost, whereas 50% of East Asian students do it because of the cost. And again, when you kind of put those things together and kind of see, the majority of Americans on these two, majority of East Asians in this one, that makes it a stark contrast. That's not as easy to see. I mean, you can see a lot more Asian students do it here, but you also see a lot more American students up here in these two places. It's not as easy because the number of people doing that was not the same. The key as you're going through any of these things and looking at a two-way table is make sure are we talking about the percent of American students, or are we talking about the percent of students that save time who are American? All right, so knowing where that of comes in, because out of the students who save time, 29 out of 39 are American. This makes it look like 74% of the students that do it are American. It says that means Americans are going to do that a lot more often, but it's misleading because there are more American students. So we usually compare within that single group of American, within the single group of Asian students, find the ratios or the percentages, and use that to make the comparison. All right, for number 35, talking about the Mississippi River, it shows all the years and the discharge rate, and it talks about it in cubic kilometers of water for that. And the first question says, make a graph of the distribution of the discharge. So a distribution graph, remember, is typically referred to as a stem plot or a histogram. So here is the histogram that I have that shows the distribution. It shows me that about 12 years were between 483 and 600, 16 years between that. This looks relatively normal as far as that is concerned. Based on the shape of the distribution, do you expect the mean to be close to the median? I would say, yeah, it's going to be pretty close to the median because it is a relatively short. But let's take a look at both of those numbers. So if I do the average of the first column and I do the median of the first column, they're pretty close together. You'll notice the average was slightly to the right of the median because, again, if it were skewed, it would be skewed slightly to the right. But yeah, that tells me also it's a relatively normal distribution. It then says, does it seem reasonable to use X bar and S to describe the center and spread of the distribution? X bar being the average. Yeah, I think it would be. The standard deviation of this looks like 136. So if you were to think about those things in terms of between 136 more and 136 less, I'm looking at 68% of the years are between 430 and 690, which looks pretty close. Look at this graph. All of the things seem to be between 430 and 690. Going on to number 36, it says, use this data and make a time plot that shows how the volume of the water in the Mississippi changed over time. All that's asking us to do, and it's not a very common one, is I'm going to now insert a chart that uses both of these. And here it is discharge versus year. And it shows how the water rate has kind of changed over time. All right, you'll notice it goes up and down pretty dramatically. Now, if I'm looking for a trend, I'm going to use a scatter chart, and I'm going to use the scatter chart to kind of put a trend line in here and see that it seems to be gradually increasing, but not very quickly. I can use numbers like R squared to say whether or not I can use this to really make a prediction. And the R squared in this case really doesn't show much. The other thing to remember is that this is really just talking about the year. the year, I don't think I can make a prediction just based on the year. I can see that it's gradually going up, but I can't really make much of a prediction because this only describes about 18% of the variation. So scatter chart really doesn't help in that case. Whoops, I didn't want to delete it though. Just wanted to look at it, and this shows you just how varied, how much variation there is from year to year. It says, what does the time plot reveal that the histogram from the previous exercise doesn't? The fact that this shows us the changes over time, whereas the histogram really just shows us how many of the years had certain amounts of discharge. And is it a good idea to always make a time plot of time series data because a histogram? Oh, it says it is. It doesn't ask. It is a good idea. So since this is a time, here's that time plot, the connected version of it. And again, the reason these ones really are in there is so that you don't confuse as you're looking at single variables. That's when we use our histograms. We use our mean and median. When we have time series, we use a time plot, not to be confused with the things like the scatter charts and the two variable statistics. All right, problem number 47 asks us to talk about how a school is doing, and here is a two-way table that shows the responses from black parents, Hispanic parents, and white parents. One of the things about this table you'll notice is that each group is relatively evenly distributed. So you could look just at the numbers and kind of make some comparisons, but typically the first thing we would end up doing is doing our marginal distributions, which is our totals that are here. I'm going to take this same set of data though, and I'm going to also, I'm going to copy it. I'm going to make a second table that shows the percentage of black parents that think their students are doing excellent, etc. So again, I'm just going to use equals this divided by, and I'm going to lock it to this row down here. Row 7. And I am, because of what I'm about to do, I locked it down to that row, so it always divided that way. And that way when I reach over, all of these are divided by C7, all of these are divided by D7. So I locked the row and not the column. Not really important, as long as you understand that you are finding the percentage of students by doing, or the percentage of opinions in each group. So looking at these two things and kind of making an analysis of it, one other thing, let me go one more over here. This is probably what most people are going to look at. They're going to highlight the fact that 33% of our parents, or maybe 44% of our parents, think our school is doing excellent or good, in the top part of it. In fact, if you think that fair to excellent is probably a positive response, you could look and say, overall, about 80% of the total there. If you look at each individual group, though, I think you're going to notice that one of the groups, especially for Hispanic parents, there's a number of them that say that they're doing excellent, but it has the largest percentage of people who think that it's doing fair in here. Another thing that stands out is black parents have the lowest percentage of parents who say that it is actually doing excellent. Just about all of their responses were good or fair. Everyone seems to agree, pretty much on the poor side of things. It's about 11% across the board. And a few parents said they didn't know. I guess this is where you look at this and say, maybe make a conclusion that, does it look like the white parents seem to be more active in their school because they seem to know more about what's going on? They're much less than the other two. But overall, because of the even groups, those are some of the statistics that I would be highlighting as I'm looking for some of the differences. The low percentage here, for doing well. I suppose the highest percentage of, where was it? I thought there was one other one that we had. I'd also be taking a look on, here's a pretty high percentage. comparatively. I'd also be looking at each group compared to the overall and saying like, yeah, they're about the same across the board here. If the average is about 32%, more black parents say fair than normal, more or much less Hispanic parents say that they're doing good. And as far as excellent, this is the surprise one. I think that was the other one. This is a pretty big difference compared to the other ones. That might be another stat that you highlight when you're comparing them. Overall, it looks like about 70% of the parents think that it's doing okay or better. 11% of the parents kind of find that it's in poor shape, or you could look at it as these two together, 44% up here and about 44% down here, 43. It ends up seeming like it's pretty split if you think fair and poor are the bad ones. Again, if you take a look at the other groups though, in the black parents, only 39% on the top two as opposed to 48 in the bottom two. Hispanic parents, 43 and 41. White parents, 50 and 40. So putting those groups together, looking at each one individually, comparing it to the overall group, understanding how you can add some of these percentages and say like, oh, here's 70%, 60, or about 70, 80% by putting them together. You have to do the analysis though, but that's my takeaway is it's relatively evenly distributed with a couple surprisingly high numbers in here. But overall, I also have good representation from each group. So my total numbers are actually pretty accurate comparatively. But that's number 47. Hopefully those things will help you as you are getting ready for the test on Friday.